Welcome to the Basic Electronics series. In today's session, we will learning about basic electrical concepts and resistor circuits. Here is the agenda. So, application of electronics engineering, difference between electrical and electronics, electric charge, voltage, current, resistance, Ohm's law and numerical examples, electrical power, energy and efficiency concepts, then series circuit and parallel circuit. So this is the application of electronics engineering. So we using in communication system, computer technology, consumer electronics, medical equipment, industrial automation, power electronics, defense and aerospace. So we are using electronics in mobile phones and smartphones, PC, laptops, television sets, X-ray robots. The difference between electrical and electronics is very easy. By seeing this figure only, you will get to know what are the difference. So this is large, bulky, heavy, but this is smart, compact and lightweight, right? So here we using high voltage, high current, high power, but here we using low voltage, low current, low power. Let's see the difference. So in electrical mainly uses AC current, but electronics uses DC current. So electrical deals with generation, transmission and distribution of electrical power, but electronics deals with small electronic circuits, chips and signal processing. The components are used in electrical is generators, motors, transformers. These are heavy, but in electronics we are using resistor, capacitor, diode. These are lightweight. So electrical is analog only, means it is continuous with respect to time, but electronics is both analog and digital. Let's see what is the electric charge. It is the fundamental property of matter. Okay, when placed in an electric or magnetic field that causes it to experience an electromagnetic force. So there is existing two types of charges. One is positive and one more is negative. See in this diagram, the positive and negative charges are attracts, means the opposite charges will attract and like charges will repel, means plus plus, minus minus, these are repel. So the unit of charge is coulombs. It can be represented using C. So the constant value of charge is 1.6 into 10 to the power minus 19 coulomb. Next is the voltage. We can represent voltage using the letter V. So what is voltage? See this diagram. So here something pressure is taken, right? So voltage means pressure from electric circuit power source that pushes charged electrons through a conducting loop, enabling them to do work. For example, illuminating light. Okay, so it can also called as potential difference or electromotive force. The unit of voltage is V, volt. Okay, it can be represented using V. Formula of V, so it can also defined as the amount of energy per unit charge, or W by Q, work by charge. And from Ohm's law we got V equals to IR formula. Next is the current. It can be represented using the letter I. See in this diagram something is flowing, right? This is nothing but electric charge. So the current is nothing but the rate of flow of electric charge through a conductor. The unit of current is ampere. It can be represented using the letter A. So formula I is equals to charge by time. There is also, in this definition you know, right, the electric charge through a conductor. So charge per time. There is also one more equation, V by R. This is we got from Ohm's law. Next is the resistance. Resistance is nothing but the opposition to the flow of current. So unit of resistance is ohm. It can be represented using this symbol. The formula of R is V by I from Ohm's law and rho L by A. So to find the value of resistor, we need to follow the color code. There is a code for each color, okay? Black having 0, brown 1, red 2, like that. So in this resistor, first band is yellow, which having 4, violet 7, orange 3, this is gold, plus or minus %. This is tolerance. The first two number write as it is 47. For this band, you need to write 10 to the power number. Here number is 3, so 10 to the power 3. If it is red, 10 to the power 2. Now this is become 47 into 10 to the power 3 or 47,000 or 47k ohm is the unit. This is the resistor symbol. So what is Ohm's law? The current through a conductor between 2 points, current means I, is directly proportional to the voltage across the 2 points and inversely proportional to the resistance. So I is equals to V by R. We can also say it like this, V equals to IR. So in this figure, see, we can easily find what is VIR. So keep your finger on V, then you will get I into R. So V equals to IR. So I equals to V by R equals to V by I. So I is nothing but current, R is nothing but resistance and V is nothing but voltage. So these are the numericals which is most frequently asked in the interview. So an electric heater draws 3.5 amps from a 110 volt source. Here amps is nothing but current, ampere, right? So volt means voltage. So now we need to find the resistance. We know I, we know V. And we know the formula from Ohm's law, V equals to IR. Rearrange it, R equals to V by I. Substitute the value, then you will get the answer. Next, electric power. So what is power? So the power means how much energy you have. That is nothing but power, right? So the electrical power means the rate at which electrical energy is consumed or transferred. The unit of power is nothing but watt, kilowatt, megawatt. So power formula is voltage into current, V into I. So we know that V means V equals to IR. Substitute in the place of V, then you will get I square into R. So I equals to what? So V by R, right? So substitute, then you will get this formula. So next is the electrical energy. Energy means how much you have done work over a period of time. That is nothing but your energy. But electrical energy means the total amount of electrical work done over a period of time. The unit of electrical energy is joule, kilowatt hour, watt hour. So this is the formula. Energy equals to power into time. Time means T, power means V into I, right? Substitute. So V means V equals to IR, then you will get this formula. Conversions. 1 kilowatt hour means 3.6 megajoule. Mega means 10 to the power 6. 1 watt hour means 3600 joule. So next is the electrical efficiency. So it is the ratio of useful output power or energy to the total input power or energy. It can be represented, the unit is percentage, okay. So it can be represented using this symbol beta. So the formula of efficiency is output power divided by input power into 100%. It can also write it like this: useful energy by total energy into 100%. So these are the problems which is asked in the interview. So the calculate power consumed by a 220 volt heater drawing 10 amps current. So calculate power. We need to find power value. We having V and I value. This is V and this is I. We know, right? Power equals to V into I. Substitute the value, then you will get the answer. So to write it in terms of kilo, just divide it by this 1000, then you can write it like this. So a 60 watt lamp operates 8 hours daily. Calculate monthly energy consumption and cost. So daily energy, we have a formula P into T, substitute power and time values. So you should convert it to K, means divide it by 1000. So we got the value of daily energy, but we need monthly energy. So 1 month having 30 days or 31, okay. So now multiply this with 30, then you will get monthly energy. So we need to find cost, right? So for 1 day 0.15 kilowatt hour per day, okay. Per kilowatt hour cost is 0.15, but 14.4 kilowatt hour consumes how much cost? For, you can write it like this: for 1 kilowatt hour consumes 0.15, okay, 15, but 14.4 consumes how much? Just multiply, then you will get the total cost. Next is a transformer has input power 5000 watt and output power 4800 watt. Calculate efficiency and loss. We know the formula of efficiency: output power divided by input power into 100%. Substitute the values, then you will get this answer, okay. Losses. So 5000 is the input power, output is 4800. You have given 5000 rupees and you got 4800. What is the loss? 200 is the loss, right? Like that only here the loss is 200 watt. Types of resistor circuit, okay. There is 2 types. One is series circuit and one more is parallel circuit. The resistors connected one after another like chain. So here same current flows through all circuits. To find the total resistance value, we need to add the values of individual resistance. So in this circuit, the total resistance is 4 plus 4 plus 2 plus 2 plus 3. So 15 ohm, right? Voltage divides across resistors. So the parallel circuit means resistors are connected side by side. It's like ladder runs. So same voltage across all resistors. And here current divides among resistors. Total resistance is less than smallest resistor. So 1 by R total is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So let's solve this problem. So 1 by 8 plus 1 by 8 plus 1 by 4. So simplify 1 by 8 is 0.125 plus 0.125 plus 0.25. That is 0.5. But we need to find the R total value, not 1 by RT, right? Take inverse, then you will get the value of R total. So these are the basic electrical concepts and resistor circuits. For more videos, please watch the upcoming videos. Thank you all.